Good morning, everyone. In this video, I'm going to explain about standard and canonical forms. In these standard and canonical forms, we need to know about what is minterms, maxterms, and expression functions as a sum of minterms and product of maxterms, and that function should be in canonical or standard forms, and two-level implementation of a standard forms. Minterms. Consider a system of a three input variables that may be x, y, and z, and a term which ANDs all input variables either in the true or a complement form is called minterms. And example of a minterms is, for example, if we need to take any three input variable that is x, y, and z, that three input variable having the total of 2 power 3, that means 8 minterms. That may be x bar, y bar, z bar, x bar, y bar, z, x bar, y, z bar, x bar, y, z, x, y bar, z bar, x, y bar, z, x, y, z bar, and x, y, z. It is basically 2 power 3 means it having the 8 minterms. That means that if it having the 3 input variables, 3 means x, y, z. So these 3 input variables having the values called 0, 0, 0 to 1, 1, 1. That means total of 2 power 3, 8 minterms. So based on that input 0, 0, 0, we may consider that is x bar, y bar, and z bar like that. If it is all 1, it may be x, y, and z. Each minterm equals 1 at exactly one particular input combination and is equal to 0 at all other combinations. Thus, for example, x bar, y bar, z bar is always equal to 0 x except for the input combination x, y, z equal to 0, 0, 0, where it is equal to 1. Accordingly, the minterm x bar, y bar, z bar is referred to as minterm called M0. Second one is called x bar, y bar, z. It is the minterm called M1. Like that, the final one x, y, z, it is the minterm called M7 because it having total 0 to 7, 8 values. So that's why the minterm is called M0 to M7. In general, minterms are designated Mi, where I is corresponds to the input combination at which this minterm is equal to 1. For the three input system under consideration, the number of possible input combinations is 2 power 3 or it is 8. This means that the system has total of 8 minterms as follows. So this M0 is nothing but x power x bar, y bar, z bar. That means it represents the minterm called M0. Like that, it having the minterm M0, M1, M2 up to M7, that is x, y, z. In general, for n input variable, the number of minterms equal to the total number of possible input combinations, that is 2 power n. A minterm equal to 0 at all input combinations except 1 where the minterm is 1. Example, what is the number of minterm for the function with 5 input variable? So it may have 5 input variables. For example, it is input variables are a, b, c, d, e, the 5 variable. So it having the total number of 2 power 5, that is the 32 minterms. Max terms. Consider a circuit of a 3 input signals or variables. It may be x, y, and z. A term which are all input variables either in the true or complement form is called max terms. Whereas in min terms we are using ANDs all variables and all input variables, where here in the max terms we are using the ORs all input variables. It is called max terms. With 3 input variables, the system under consideration has total of 8 max terms, namely x plus y plus z and x plus y plus z bar. Like that, it is x bar plus y bar plus z bar for all ones. So each max term is equal to 0 at exactly one of the 8 possible input combinations and is equal to 1 at all other combinations. For example, the input variable called for example xyz, it may be 0, 0, 0 case. In that case, the max term is nothing but x plus y plus z. Accordingly, the max term x plus y plus z is referred to as max term called M, capital M0. These are the examples of the max terms. In general, max terms are designated capital M suffix I, where I corresponds to the input combination that would this max term is equal to 0. For the 3 input system, the number of possible input combinations is 2 power 3, that is 8. This means that the system has a total of 8 maxterms as follows. So the 8 maxterms is capital M0 to capital M7. So if it is in all input variables is 0, 0, 0, in that case it is x plus y plus z. If it is all ones, the maxterm is x bar plus y bar plus z bar, like that. For n input variable, the number of maxterms equal to the total number of possible input combinations, that is 2 power n. A maxterm equal to 1 at all input combinations except 1 where maxterm equal to 0. Using De Morgan's theorem, the truth tables it can be easily shown. Mi equal to mi bar. That means max terms equal to this capital M divided by max terms, where small m is nothing but a min terms. So it is the complement to each other. And maximum for all I equal to, it is 0 to 2 power n minus 1 combinations. For example, if it is I equal to 3, that means it is a 0 to 7 combinations. As expression the function as the sum of min terms. Consider the function capital F is defined as shown in figure. Capital F is the function. Now let's rewrite the table with the few added columns. A column is I, indicating the number of input combinations. 4 columns of the M2, M4, M5 and M7. one last column ordering the above min terms M2 plus M4 plus M5 plus M7. So from this table we can clearly see that cap function is M2, M4, M5. It is nothing but a sum of products. That means, so wherever we have the function called M2, this is M0, M1 and M2. So wherever we have the min terms, in that the function is should be 1. So here f equal to M2 plus M4. So in M2, in the second position it should be 1, and it is M4, M5 and M7. In that corresponding locations we are putting the 1. Expression function as the sum of min terms. In general, any function can be expressed by the ordering all min terms corresponding to the input combinations at which the function has the value 1. The resulting expression is commonly referred to as the sum of min terms and is typically expressed as f equal to sigma 2, 4, 5, 7. So in min terms is representing using the sum of min terms. So where sigma indicates ordering the indicating the min terms. This is f equal to sigma 2, 4, 5, 7. This is representing as M2 plus M4 plus M5 plus M7. This is the representation of the min terms. It is also called as the sum of products. Express the function as the sum of min terms. Consider the example f and f bar. See the truth table, and here f bar means it is nothing but a complement of the function f. F bar equal to M0 plus M1 plus M3 plus M6. And this min terms, this function can be represented as sigma 0, 1, 3, 6, as the suffix indicates that the min terms. And capital F is nothing but a complement of this f bar. So whatever we don't have the min terms here in this sigma 0, 1, 3, 6, other than these 4 variables, we are putting in a complement form, that is 2, 4, 5, 7. So the sum of min terms expression of f bar contains all the min terms that do not appear in the sum of min terms expression of f. Thank you.